Do you eat? Well then, this concerns you. Many huge problems today endanger our food production and even all life on Earth. These problems include climate change, erosion, the pollution of water bodies with excess nutrients, and the loss of fertile soil. Food cannot be produced without the nutrients nitrogen and phosphorus, and we have no substitutes for them. However, phosphorus is running out, and nitrogen production requires huge amounts of energy. These problems are acknowledged here in Finland, where we're working to find practical solutions. Back in 2010, the Finnish government promised to pioneer the recycling of nutrients, especially nitrogen and phosphorus. Nutrients leak into water during every stage of the food cycle, from the farmland where our food grows to the cities where food is mainly consumed, and where our organic wastes and wastewater sludge contain large amounts of nutrients. In the soil, these nutrients enable our food crops to grow, but if excess amounts of nutrients leak into rivers, lakes, and the sea, they provide food for harmful algal growths. This deadly problem, known as eutrophication, is afflicting many water bodies today, including the Baltic Sea. Nutrient recovery and recycling must start on the farm, since nutrients are mainly used at farms to grow crops and raise livestock. It has been estimated that in Finland, we could replace up to 80% of chemical fertilizers with recycled nutrients from manure and other sources, together with good agricultural practices. Instead, we currently use chemical fertilizers for 240 million euros per year. The industrial production of nitrogen fertilizer requires huge amounts of energy. In effect, a fertilizer manufacturing plant like this converts fossil fuels into fertilizers. Phosphorus is a limited natural resource that is both essential and irreplaceable. Without phosphorus, there can be no life. Today, our farms still largely use the mined and scarce phosphorus. In many cases, an excess of phosphorus is added, which causes leakage into the waterways. This makes no sense. Meanwhile, our soils are degraded for the lack of proper care. Thankfully, carefully nurturing the soil can help us solve a whole range of problems, from soil degradation, erosion and eutrophication, to phosphorus source depletion, food shortages, and even climate change. So, to solve the problems of planet Earth, we should start by looking into the soil that covers it. Poorly maintained soils do not function well. The soil structure is degraded, and they lack vital organic matter, meaning material containing carbon. Such soils cannot retain water, so vital nutrients are easily leaking away or evaporating from the soil's surface. Without the correct amounts of organic matter, nutrients, water, and air in the soil, there can be no biological activity. The unseen work of worms, fungi, and bacteria, and countless microscopic bugs convert soil nutrients into forms that plants can use. Nurturing the soil must start by analyzing the soil, focusing on nutrient balance, amounts of organic matter, and microbial activity. We must then feed the soil according to the needs with the right nutrients. Soils, like humans, need to maintain a nutrient balance. Shortages or overdoses of a single nutrient can be crucial. We must also add organic matter to the soil and ensure that diverse catch crops are present in the soil all year round. If all this is done properly, fields become carbon sinks, that is, storage for carbon. Enabling soils to capture carbon is a way to reverse climate change, as pointed out by recent global climate initiatives. Nurturing our soils improves their fertility and increases crop yields, while also reducing nutrient leakage and eutrophication by keeping nutrients in the food production cycle. This is also essential to ensure that there is enough food for the Earth's growing population. We need to analyze the soil to know what it needs. Then we need to treat and optimize the manure or other recovered nutrients to refine them into fertilizer products to meet the demands of the soil and the crop. This can be done on the farm level or on larger scale at biogas plants and other biorefineries. Organic waste from our homes can also be recycled back into food production. With proper treatment, so could the wastewater sludge from the cities. To optimize microbial activity in the soil, we can add carbon contained in byproducts from the pulp and paper industry. We need to maximize the use of nutrients containing side streams from all sources to match nutrient demand and supply, with everything effectively recycled. This provides a good practical example of the circular economy and the bioeconomy in action. So this is what Finland is doing today. We aim to effectively pioneer nutrient recycling and carbon farming, while making our food production truly sustainable.